Alright, so welcome. This is 8.4. We actually do not have any vocab, but we're just going to go through a couple problems. So we're going to first talk about our angle of elevation. So we're going to write that angle of elevation, and we have angle of depression as well. Let's do that in blue. So I have angle of depression. Alright, and so depression. And so both of these angles right here come from a straight line of sight. So let's take a look at this guy and his hot air balloon. So he has a straight line of sight. So these angles always come with straight line of sight. So if I am looking at a straight line right here and all of a sudden I am looking up, excuse me, that is my angle of, I'm elevating up, that is my angle of elevation. If I'm looking straight out and all of a sudden I look down as if I'm like depressed and sad, I look down, that is my angle of depression. So let's just label all these right here, either angle of depression or angle of elevation. So let's start with elevation. If this guy right here is looking at a straight line of sight and all of a sudden he is looking up, that is my angle of elevation right there. Okay, you can color code it or you can write angle of elevation if that works. If we have a person down low and he says, oh, look at that person up there in the hot air balloon. He has a straight line of sight. All of a sudden he looks up. That is my angle of elevation. If, let's go blue. If this guy right here all of a sudden sees this person down at the bottom of the mountain and he has a straight line of sight and he looks down, this angle 3 would be my angle of depression. The seagull is up here. He's looking down at the hot air balloon. He's got a straight line of sight. When he looks down, that is my angle of depression. Okay. So if he's going up, he's elevating, angle of elevation. Going down, angle of depression. Okay. So let's just do a few problems. All right. So my first problem says, suppose you stand 53 feet from a wind farm turbine. So we have here's 53 feet. The person is. Your angle of elevation to the turbine is 56.5 feet, so there's 56.5. Your eye level is 5 feet above the ground. Approximately how tall is the turbine? Okay, so we have, here's my right triangle that we have right here. This person is looking up, it's 53 degrees away, so let's solve for x first. So the first thing that I am going to do is, we have, here's my line of sight. He started here, he's looking up. Well, we can solve this through our trig functions that we just learned. So we can solve it through SOHCAHTOA. Let's see. Again, I'm always going to write this out. So SOHCAHTOA. So if I'm looking right here, and if I'm looking this way right here, this x is going to be my opposite. The 53 is going to be my adjacent. And so I'm looking, well, opposite over adjacent, that's going to be tangent right there. So I'm going to take the tangent of 56.5, and that's going to equal my opposite, which is x, over the adjacent, which is 53. And we're going to solve. So to get x all by itself, I'm going to multiply both sides by 53. Those cross off right there. And then in my calculator, I'm going to put in 53 times the tangent of 56.5. And that is going to equal, I put that in my calculator there, that's going to equal 80.07. Let's just round, let's just say this is 80. So I'm going to get right here, x is going to equal 80 feet. Alright, that is not my answer for this case. We just solved for x. In this case, though, it wants us to know a little bit more, though. So we said this is, this is going to be 80 feet, what x is going to equal, and this is 80 feet, but it wants to know how tall the turbine is. Well, so far x is only measuring this right here. That is the only thing x is. Well, it told us in the very beginning, though, that this person, your eye level is 5 feet above the ground. So this person's looking straight out, but he's only 5 feet tall, 5.5 feet tall, so 5.5 feet tall. So if we want to know how tall this whole turbine is, my answer, combine those together, is going to be 85.5 feet. Approximately, it's going to be that tall right there. Okay? Alright. go to the next one. Alright, my last problem right here is, so we approach the runway 17, so at this airport in Oklahoma, the pilot must begin a 3-degree descent. So we see, here's the plane, he's got to begin a 3-degree descent, starting from the height of 2,014 feet, so that's how far he is above sea level. The airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far away is the runway from the airport at the start of the approach? Alright, so we want to know this. So what are we trying to solve first? Well, we're going to try and solve this approach. From the airplane to the airport, we want to know what is this going to be. We are trying to solve for that distance. Okay? Well, the first thing that I know right here is I know that from the airplane to straight down to the ground, the ground is perfectly horizontal, and that straight down is perfectly vertical. So we just made a 90-degree angle right there. Okay. Well, it did give us a little bit of information. It did tell us that we do have this sea level right here. Here's our sea level. There's my sea. And it told me that the airport right here, from here to sea level, is 1,700 feet. Okay? It didn't help me too much because I want to know about this triangle. But it did tell me that this airplane is 2,714 feet above sea level. And if the airport is at 1,007 feet, wow, above sea level, then I want to figure out, well, what is this distance right here? So if this is that distance, and this is how far it is above, all I'm going to do is I'm going to take this 2,714 and subtract it from how far that airport is above sea level. So I take those 2,014. When I subtract these two right here, I'm going to get 1,707. So that is this distance right here. That is this red line right there. Perfect. Alright, so let's see. I'm going to redraw this triangle to make it a little bit clearer for me. So I have, here's this triangle that I have, and there's that right there, and we said that was perfectly right, and we have this 1,707. Alright, but we don't have much more information. It did tell us, though, that he is going to make a 3% descent. So if this right here, when we drew this, it was a straight line. So if he's looking perfectly out right there, that is also a perfectly horizontal line. And if he's going to make a 3% descent, well, we know that from his point of view, down is a perfectly straight line. From his point of view, out is a perfectly straight line. So what does that mean, though? That means that this is a horizontal and a vertical, and they meet together to make a right angle. So if that's a right angle, and if this little portion right here is 3%, what is this other portion going to be? Well, that other portion is going to be 87%. And so we have 87%, and we're trying to figure out what that is right there. So now that I have a couple things filled out, we can now solve. So again, first thing I'm going to do is I'm going to write my SOHCAHTOA. SOHCAHTOA. I'm going to write my SOHCAHTOA. And if I'm using this angle right here, and if I'm looking at this right here, let's change this to red. This is going to be my hypotenuse. So that's my hypotenuse right there, and this right here is going to be adjacent. Alright, what am I using? I'm using adjacent and hypotenuse, so that's going to be my cosine. So I'm going to take the cosine of 87, and that is going to equal the adjacent, which is 1,707, over whatever the hypotenuse is. We don't know. We want to solve for that. Okay. So I want to get this x to be all by itself. So I want to get it out of the denominator. So I'm going to multiply both sides by x. That way, boom, it's out of there. It's out of the bottom. Well, what am I left with? I'm left with x times cosine 87 equals 1,707. Alright, well I want that x to be all by itself. So what do I need to do? I need to divide by cosine 87. So that way those are gone. And I'm left with what I do to one side, I do to the other side. And so now I have that x all by itself. This is going to give me x equals, and when I plug that into my calculator, I'm going to get cosine 87. I'm going to get 3,216, and we'll just round that right there. He's about that far off feet from the ground right there. So that right there would be my final answer. Okay? Alright. See you guys soon.